Good afternoon, everyone. Welcome. This is going to be Windows Phone Maps for Developers. I am Mike O'Malley. I'm a program manager on Windows Phone working on Maps. First order of business, originally this was going to be a Nokia presented talk by some of my counterparts, but it'll be presented by me today. And second, it's jam-packed full of content and demos, and so if we could hold all the questions at the end, we'll take questions at the 4 microphones at the end. Thank you. So today we're going to go over the map architecture of how we actually integrate Nokia's HERE platform into Windows Phone. I'm going to go through some of the common use cases that developers use the map control and other APIs for, and demo some of the apps. I'm going to do an API walkthrough that pretty much covers all of the map APIs, and then do a demo that ties a bunch of those different APIs together, and then some key takeaways I want you guys to leave here with. So first off, I said I worked on Windows Phone Maps. Inside Windows Phone Maps, there's actually 2 teams. One is the Maps app. They're essentially the app that you see on your Windows Phone called Maps or any other local experience, such as Local Scout. And then there's me on Map Platform. And so my job is to provide both to the Maps team and to third parties developer APIs on top of Nokia's HERE Map platform. So try to show you how I think about the world when day to day. I try to treat all of the apps, whether they're first party or third party or written by Nokia, equally. We define one API functionality that we're going to expose to all of them. And so essentially, if along the way we get feedback from one of those audiences that they need something, we go and insert that in for everyone. Underneath the mapping APIs we expose is the HERE platform from Nokia. This is where we get our vector map renderer that allows us to do rotation, has offline map support, has services such as routing and geocode, all in one spot. One really unique thing about the HERE platform is that it has shared offline maps ability. So this means is any app on the system decides to download a map of San Francisco, when you start up your next app, that map's already there. So this is essentially shared on the phone. It's one of the few cases where not everything you do in the app is inside that isolated storage container. So if you've been developing for Windows Phone since Windows Phone 7, you'll be like, wait, this sounds very different from what I'm used to. And it is. We actually have 2 map controls, and the naming of them didn't make it any easier to tell them apart. So the first one is the one we've had since Windows Phone 7, the Bing map control. It is based on Bing tile maps. We've deprecated it in Windows Phone 8 in favor of using the Windows Phone 8 map control that's built on top of our Windows Phone map platform. One thing I drew on here is the green box. That shows what actually lives inside your Zap. So when you use the Bing map control, you're including a DLL when you add a reference to it that includes that DLL in your app container. And so there's a couple megabytes there that you're handling. And then on the flip side, with the Windows Phone map control, the OS has the map control in it, and you're just accessing OS resources to show that map. That is also why you'll see later that we have a capability that allows you to use the map, and that's because you're accessing something from the OS. And so to tell them apart, if the name after Windows Phone is controls, it means it's the Bing one. If the name after Microsoft Phone is maps, it's the Windows Phone 8 one. All right. So there's some really cool advantages we get out of this OS map control wrapping the HERE map platform. One is we get super smooth vector maps with legless push pins. We can do this because from touch input to updating your XAML POI location on the map is all handled without having to have a single tick on your Silverlight UI thread. We do this all off thread. The HERE map platform is navigatable in over 110 countries around the world, including China. And the shared maps across all the applications, and the ability to have the user download and use your map experience whether it be the routing, geocoding, or the map display, all when they have no data connection. One disadvantage I do have to call out is we have limited support for custom tile sources. So this is essentially the ability to put a tile on top of the map. We're not very good at it for, let's say, if you want to animate a bunch of tile sources like your weather map, or if you want an offline tile source that you store locally on your device, or if you're going to replace the entire map surface with this new, let's say, topo map you've downloaded. We're just not a great fit for that. And we've heard the developer feedback. There's a great site, I don't know if you guys have seen it, the user voice. I think last I checked, there's around 800 votes for us to improve custom tile sources. And just want to let you know we do see that feedback, and it's very important, so keep it coming. All right, so when we look at the apps that have been built in the marketplace, there's a couple key scenarios that have been coming out that people use it for. One is store or business locators. Another one that's kind of emergent since Windows Phone 8, I think it's mainly due to the background execution with location, is like tracking and fitness apps. Another one is like check-ins and geocaching, and then a very common one is getting directions to places. So I'll demo a couple of the apps today that use these quite nicely. So the first one is going to be check-in. So this is on Foursquare. What I like about Foursquare is you look right up at the top, you'll see there's the map control that zooms around and zooms into where you are. And then if I go down and select somewhere, it'll very nicely move the map over to it and put its own custom overlays on the map in those places. And then if you scroll down in info, they have both a get directions and address. And if you tap on get directions, it'll bring you to the ability to get voice guidance directions to your location. And if you tap on address, it will bring you to the built-in map experience and plot that on the map, and you could save that to your favorites or get walking directions if you're closer than something you're going to drive to. Next, which is more of is OpenTable. It's a good example of like a kind of a fancier store locator. Instead of you having all your properties you're listing a bunch of others. So let's say it's going to be in San Francisco this evening. I want to get a table for 2. I can find a table and wait for the results to come back. And then they'll very nicely show it on this little map. And then, oh no, thank you. Thank you for letting me know. All right, we're back. I can filter this down and just say, let's say I just want to look at, let's say, I'll do American cuisine. And then tap on the map, and you can see all those nice poise. They're not lagging. They're nicely positioned. I can zoom in. And because these are XAML overlays, I can actually tap on them, and they flip and animate like any other XAML element would, all staying nicely tied to the screen. And then lastly is Runtastic. It's a fitness app, and one of the things, they have all their different pages all in pivot, so you can go back and forth, and one of them's a map. And this is actually something pretty hard to get right, and I like that they did it. They make it so I can't move the map when I'm in the pivot, but then they gave the ability to unlock it, and then I can free pan the map. In others, since this is like a running app, they turned on some of our neat features such as 3D landmarks, like that building right there. And then they have all these little squiggles, which are actually stairs. And so we actually have the stairs that pedestrians can go on. And so that's an extra feature you can turn on. So our map platform consists of a bunch of different APIs. Mainly when you think about maps, you think about the map control, the display surface itself, and then on our platform with our offline support, we've added the routing, geocode, and reverse geocode APIs. In addition to that, we have tasks that allow you to launch into first-party map experiences from your apps. And then we've defined a couple URI schemes that allow you to have us launch into you, or that you can register for and and launch into yourself. And then lastly but not least, because you're building a map, most likely you're going to need location, and we'll go over some of the location APIs. And across both the map control and map services, we didn't get everything in the Windows Phone 8 product that we wanted to, and there's a couple things that we thought would be really useful to get out to developers as fast as possible. And so we actually made a couple extensions and put them inside the phone Silverlight toolkit. And you can go download that at phone.codeplex.com. So when you're building a map and location app, there's several common pitfalls. One that I think everyone at Microsoft I worked with has hit, and I've gotten tons of mails about, is this capability you need for this new map control. And if you don't set it in your project, you're going to get this really weird XAML parse exception. We tried to make it prettier. We really couldn't, so we just have to, we put in all the documentation, make sure you set this IDCAT map in your manifest. Since you're building a map application, most likely you're going to need location, so when you're in there, you can set location as well. One thing that a lot of people are missing, we're seeing in their app submissions, is they're forgetting to put in the dev ID and token for the control and services usage, and so please, please, please do that. You can get that through the developer portal, the App Hub at dev.windowsphone.com. After you do the first step of the app submission process, even before you upload a Zap, there's an option near the advertising section at the bottom of the page called Map Services. You click in there, and we generate an ID and token for your map usage. And then if you're using location, do remember to create a location consent page at the start of your app. If you forget to do that, you'll get rejected from certification, and that you don't want to slow down your path through Marketplace for something like that. So with the map control, I'm first going to go over what you can do with our base map and what we give you. So the first part is our cartographic modes. We have 4. One is a simple road grid with all the street labels, all drawn in vectors. The next is aerial view, which actually uses satellite imagery. And then we have a hybrid view that takes the satellite imagery and overlays just the road network from the road display onto it. And then lastly, we have a terrain view that shows the contours of the land as a relief. Once you've selected your base map, there's a few extra switches you can use. One is to show those 3D landmarks. That's very simple. It's right on the map control. It's called landmarks enabled. You just set that to true, and you're all set. And then to turn on all the stairs and elevators for pedestrian traffic, you just have to set pedestrian features enabled equal to true. One of the really neat things about having vector maps is that if you switch any of these modes or switch between light and dark, you don't have to wait for new tiles to download. It just instantly switches over because it's just a color scheme change. And this light and dark is really nice. I know a guy on the team that before we had this, he was getting his directions on his phone in his car and got pulled over for texting. And it was really just that he had the map on light theme on, and they thought he was texting. And so it really makes a difference if you're in a low light situation or your app is in it or you know it's late at night to change the map over so if you don't cause any of those scenarios or cause pupils to dilate when they don't need to in the dark. So once you've gotten that base set up in your app and what you want, next thing you're probably going to want to do is move it around, because when you load it in by default, it zooms out to show the entire world. And so you're going to want to change that to show the area you care about. And so we have this set view method that provides smooth animations around your map. We allow you to set the center as a geocoordinate, the zoom level, a pitch angle, and the rotate heading degrees. And you can do this together or separate, and so you can animate just one of those properties or multiples all at once, and we'll take care of all the math to do that. When you use set view, you get one or more calls to a view changing event. You only get one call if you say you don't want an animation, but if you're going to have an animation, odds are you're going to get that met several times. But we guarantee you only get one view changed raised at the end. That means we're done with moving it. One place we moved away from what the Bing control was doing is we decided not to have these view changing and changed be raised on user interaction. We thought it was going to slow down the overall user performance of the map. And so we don't do that. If you really need that for some scenario you're doing, you can gently look at the center and try not to do too much when you get that callback. And then render complete is an event that we raise whenever the map is idle. So this is a very frequent one. So essentially, any movement of the map that causes more data to have to be loaded into memory and then displayed to the user will cause this to get called when the map is fully visible to the user. So once you've gotten your base map, you've now positioned yourself on the map. Now you're going to want to add your content to augment the map. And the primary way of doing that is just put your own UI elements from XAML in there. We expose this map overlay, essentially content presenter, that allows you to add a UI element in. If you need to make your marker up of multiples, which you probably will, you can add that to a grid before you add it to the map overlay. Then you can take one or more map overlays and add it to a map layer, which is a logical container of map overlays. So essentially, you could put stores in one and gas stations in another or something like that, so you can easily toggle them on and off. And then you take these multiple layers and you add them to the layers on maps. And the map overlay is really the one that's doing all the hard work. That's the one that we update the position when you pan around and zoom off thread. You set the geocoordinate, and we'll always keep it there. One important thing to realize after you set that geocoordinate is, by default, that means the upper left-hand corner of your UI element. And I haven't seen many map POIs that you want to point at it with the upper left-hand corner. And so most likely, you're going to need to use position origin and adjust where that geocoordinate is on your overlay. And so, for example, the one in the screenshot, that would probably be 0.5 in the X direction and 1 in the Y direction for your position origin to make it stick to that bottom center. So here's the stuff that we didn't get to, and we got into a toolkit for you. The first one is the maps item control. So this is something Bing had. This allows for data binding to a collection that we display of map overlays. And then we do want to keep all the UI as consistent as we can across the maps for the user. So if you don't have a specific case where you want to have your own brand element on the map, you should feel free to use this pushpin content presenter we made, such as you can see in the example there, that makes a pushpin that looks just like the ones we use in our first-party map experience. And then we also have a user location marker, which is the little diamond with the theme color dot in the center to mark where the user's position is. So after you do your UI elements, those are all pretty much in screen space when you do sizing on them. There's sometimes that you actually need it in the map scale space. And so for that, we exposed ways to draw both polylines and polygons using the Here platform itself. And so these are a couple examples of uses of polylines. The one on the right is a little fitness tracker around the Microsoft campus, and you can track your time on the different little tracks. One thing I found when I was looking for good screenshots for this, no one's really used the polygon very much. So I encourage you, try using Polygon, and maybe next time I'll use your app. And then last but not least, tile sources. Our tile sources in this release are good for online tile scenarios, especially ones which have opacity to the base map, and they're just used to lay on top. And so there's two examples from the Here Maps app. One is their Venue Maps implementation, uses tile sources, and then their traffic overlay as well. Come on. All right. So on to services. The first service we have is routing. Routing, just like display maps, available offline if you don't have a data connection. We provide both walking and driving directions through this API. And also we do multi-waypoint routing. So it doesn't just have to be from point A to point B. We can have multiple points and we'll give you multiple separate legs. One neat thing we added is the ability to easily add this to your map through an add route method on the map control itself. On the previous Bing control, you'd have to get back the REST results from your route and then take each segment apart and make a separate or add it to your polyline. But with this, if you use the built-in routing, it's just there. If you want to get routes from another source, you can, but you'll still have to do that polyline trip like we talked about that you had to do on the Bing control. The other thing we added is in each of the maneuvers, we build a UI localized string for you. So we'll obey the system UI language and give out that route so you don't have to worry about localizing your results to your users. Next is our geocoding services. We have two. One is reverse geocode, probably the one I see used more often. It takes a lat long and converts it to a civic address. Common case for that is any map application you press and hold and it drops a pin and it tells you what's that address at that pin. That's using a reverse geocode. Geocode does the inverse of that. It takes a civic address and turns it into a lat long. I see this misused a lot. It's not a local or place search. It doesn't have that type of data. Sometimes you get lucky and you'll get something like Space Needle and it will actually resolve, but that's not the common case. So if you do really want a local search, you'll need to use an online local search either from Bing, the Bing local search, or Nokia Places API. All right, so we have 4 tasks. The first 2 launch into our map experience. The first task is the map task, and that is, it takes a search query and will launch from your app into ours and do that search query. That's like what you saw done in OpenTable when I clicked that address link. It brought you into our Maps app. And then the second one is map directions, where essentially you can take 2 lat longs and a name and launch off into our directions experience so you don't have to build one yourself. And the other 2 tasks are around user management of offline map data. The first one will bring the user to all the downloaded maps where they can either download more or delete ones they don't need. And the second one, the update task, will bring them to a page where they'll check to see if there's available updates. And if there are, they'll be prompted to download them. And so the Here Maps uses both of these in their map settings page. And then we have our URI schemes that we've defined. We defined an MS Drive to and an MS Walk to. These are designed for voice guidance scenarios. And so from our map experience, we use these to call out to third parties that register. So one for Drive is Here Drive, and one that registers for Walk right now is Here Maps, and it'll give you walk guidance. These take 3 parameters: a latitude, a longitude, and a name. You can see on the screenshot there that the name of Golden Gate Park comes right up in Nokia Drive. They display it very prominently. If you have multiple protocol receivers on a user's phone, you'll get a disambiguation dialog that the user will have to click through. If there's only one, it will go straight to the app. This can be used by your app. If you build a voice turn-by-turn, you can register for this app-to-app protocol. And if you are a developer that just wants to give voice guidance directions to a place, you can call this protocol and it will launch one of these apps to do it. So at this point, I want to pause. I've just given you 3 different ways to get directions in the past 10 minutes. And I want to go through why I think you should use, why each of them are important and why, and which ones you should call in which scenarios. So MS Drive to, the voice guidance one, should really be called if you are certain that your user is going to want to take that lat long that you have and drive to it right now. because it's going to launch them right into that screen you see on the right that's going to say start driving now. The other one, the map task, is more of a browse directions. So this is the place the user is going to want to go to. They're going to want to see how to get there. They may even want to do walk instead of drive. You're not really sure. Then call that one, and that will bring them to the built-in map experience, where they'll be able to select their transit mode and launch out to a navigation experience when they need to, or just save it in their favorites for later. And then going all the way back to the routing and map control, if you have this particular scenario where you need to display a route and then you need to continue and do more in your experience after they see the route, then add the control in to your app and show a route on it. But that should really be if the other ones don't complete the scenario and you're not at the end of the chain. So location. There are 3 sources of location on a Windows phone. We have GNSS, Global Navigation Satellite Systems. We support both GPS and GLONASS. We have Wi-Fi, hotspot triangulation, and we have cell tower. And you shouldn't actually be concerned about which one you're getting in most circumstances. There are a few where you need to be certain you have GPS, but most of the time, you just say how accurate you want to be, and we're going to get you the best and fastest and lowest power position fix we can for you, based on your settings. So there's 2 APIs to get location from. One is the .NET GeoCoordinate Watcher. And for this one, it only works in .NET applications, and your desired accuracy is either high or low. And this one will continuously run in the foreground of your application. And then there's the new WinRT geolocator. And this one's great because you can write the same code and it will target both Windows Phone and Windows. And for this one, you can be a bit more specific about your accuracy and give it in meters. And we have 2 different ways of getting a response back. One is a single shot, and another is continuous. And the single shot is really great because let's say I'm just starting up an app and I want to show the map control centered on the user's location, but I don't want to wait for a GPS fix if I need a high accuracy fix. I can just say, hey, give me one from before, and it'll be okay. So talking more about that, besides desired accuracy, you get to specify 2 parameters on a single shot. A maximum age of a fix. So this means that you can get cached results. So you can say like, hey, I don't care. I just want a rough position that the user's been in the past day or 5 minutes or what have you. And then the other property you can set is a timeout period to wait. So essentially, your user's waiting. You don't want to have them spend more than 10 seconds waiting for a location fix. You can say that, and the system will give you whatever it's got, the best it's got after 10 seconds. Your other option is a continuous one by using a geolocator and registering for position changed. And before you register for your position change, you set 2 properties. One is your movement threshold. So this is the number of meters you want the user to move before you get notified again. The default 0, you can get a lot of fixes that way, but if you don't need to know until the users move 50 meters, then just say, I want to be notified after 50 meters. Another nice way to help the system save power and make your app look better, because they'll have better battery life, is a report interval. This is how often you want a fix. And so if you only need a fix every 5 minutes, tell us that, and we'll give you every fix we get in that time period, but we won't ask for a fix on your behalf until that 5 minutes. So essentially that means if there's another app that's running in the background and asks for a fix within that time, you'll still get it. So it's not like you're missing out, but you can just help us save the user's battery by setting that report interval. So for both of these, there's forms of running them in the background. For the single shot, there's a periodic task. It's part of the agent model that we have for running in the background. It's a separate DLL from your app that you include in your Zap that runs. The fastest frequency of which a periodic task can be run is every 15 minutes. And so this is more if you just roughly want to track where the user is You can do a single shot. You can even get a cached location if you want during that single shot. The other cool thing about this is we run a bunch of these agents all at once at the 15-minute barrier, and they will actually coalesce multiple location requests into one, and you go and get the hardest fix it can. And so you can save, the user will be saved power that way. And then the new one that we had in Windows Phone 8 was continuous background execution. So this is you use the register for position change just like you normally would for continuous foreground execution, but you also go and manually modify the manifest to say, hey, I want to also run in the background. Now with this, there's only one app that can do this at a time. So if you're going to go down this route, you got to make sure that the user is going to want your app doing this, and there's not going to be another app that's going to be coming in and trying to steal it, like during a, let's say, drive scenario, unless you're a driving app. And also, you're limited to only 10% of the CPU. But it's your full app. This is not an agent DLL. This is your currently running app running in a new state in the execution model. And when you're running in the state, you have access to the network, you have access to storage, you have access to audio and speech APIs, sensors, shell toasts, and tile update. And there's lots of ways to get booted out of this state if you're not careful. So the first one is you don't need it anymore. As the app writer, I'm like, okay, I've gotten the users reached their destination or they've completed their 5K. I'm just gonna unregister from position changed, and then I'll stop running in the background. Everyone's happy. Then the user can go and decide to close a running app. If you go into settings and applications under background tasks, when you have one of these CB applications running, there's a special section that pops up at the top where you see the here drive plus beta written. And if you tap on that, it will actually allow you to kill that app running in the background. Another way is the user can block background execution on the lower half of that same settings dialog, and that blocks it for both your agents that are running in the background and also blocks it for the CBE running in the background. And then, since you're getting location, if someone disables the location service on the device, it's not worth running in the background because you're not going to get a fix, and so you also will stop running. The system has a bunch of ways to also terminate you. One, the safety limit on this is 4 hours of running in the background. If your app is running for more than 4 hours, it will get terminated by the system. Battery, if you run the battery down and battery saver turns on for any reason, you're going to get shut off. The phone gets into a low memory condition, you're going to be one of the first things we get rid of well before a foreground app. Or another CBE app moves into the background and now has that one app position. For all of these, we give status reasons of why you're getting kicked out. And so you're more than welcome to notify the user using something like a shell toast to say, like, hey, another app's entering, now your drive session's ending. Or, hey, you've been running for 4 hours because you're running a marathon. You sure you want to just extend this so we get the whole thing recorded? And things like that. Great. So now I'll show you a demo of these APIs. So what I'm going to build with you guys today is an app which registers for MS Drive 2, voice navigation, and then instead of giving you voice turn-by-turn right away, it's a car share locator. So this is the idea is like, hey, I'm somewhere right now, I need to get somewhere else, and I want to use a car share. And so it will show me the car shares nearby. It will give me a walking route between where I am now and that car, and then give me drive directions using voice navigation from the car to my end destination. So here we go. I'm going to start with building the map section of the app, and I'll come back to some of the app-to-app linkages at the end. So to start with, I'm starting with the basic data binding project that I've modified a little bit. You can see it still works in its original state. Essentially, in the items, these design and runtime items, I've added another property of geocoordinate so I can store position, and when we data bind them to the map, they'll look interesting and show our car positions. So now I'll just go in and modify this XAML because we no longer need to show it in a list. So we're going to comment that out. And instead, we are going to show it in a new map control. All right, so we're going to add a map control. It's called Content Panel. We're going to register for the loaded of the map control. Then we're going to use our map toolkit extensions. We're going to put in this attached property children, which makes it look a lot like the Bing map control children. Inside of there, we'll put in a user location marker that will data bind its geocoordinate to location. We'll add a map items control, and we're going to name that cars, and we're going to then have an items template of a pushpin, and inside that pushpin, we're going to show, in its content, we're going to show an image of a car. All right, and then if I go to the code behind, the first thing I need to do when I'm using the toolkit extensions is we include in the sample this map extension setup. It essentially does exactly what initialize component does, but for the map extensions. Then I'm going to set my view model items to the item source of cars, and I'm going to set my view model location to the user location diamond. Next, I'm going to, since when you first load the control, it zooms out to zoom level 2 and shows the entire world. That's not very useful. So as soon as the page loads, I'm going to immediately zoom in from that to my current location at zoom level 14, which is roughly a good zoom level to use for how far you're going to walk to a car. Next, on loaded, we do the all-important credentials entering. So this is where, on Maps Loader, is where you're going to want to set your application ID and token. And then so we're going to display a whole bunch of car pushpins on the map. And when you tap on one, we're going to get called on pushpin tap. And we're going to then launch the details page, just like you do in the normal data binding template. All right, with that, let's go over to the details XAML. So I don't know exactly what happened to the designer there, but it got a little condensed, but it still works. We're going to, opposed to the normal details page, we're going to add a map control, much like I just showed on the first page. So I'm not going to do that in detail. Then in this next lower section, I'm going to list all the walking directions that we're going to give the user. And then last, I'm going to give a big button to tap to say voice guidance. Get me voice guidance from my location to my end destination. So you can see we just added the children like before. We are using the user location marker again, and then now we're just going to show one pushpin. So when the maps are loaded this time, we're going to zoom into that same level 14 at first, just to get close to where we're going to need to be. But this time you'll see I did it with animation none, because we're just switching pages, and so the user wouldn't expect a big fly-in, so we're just going to go straight there. And then next, I'm going to call get directions. And then get directions, I'm going to create a geocoordinate collection of my start and end location I want to get directions between. So it'll be from my location to the specific location of the car selected. I'm going to make a new route query object, set my travel mode to walking, say my route optimization is the minimized distance I need to walk, and then I'm going to use a toolkit extension we gave, which actually turns routes into async events that you can use await to query. So you don't have to wait for any callback and get it later in your code. You can just write it right in line. And then I'm going to set that route to a map route property. And in this map route property, I'm going to then remove a current route if it exists, and then add my route to the map using add route. Then I'm going to set view to the bounding box. This is something you get back from a route that actually gives you a location rectangle bounding the start and end points. And then I'll add to my route list. In XAML, I'll add each of the different maneuvers. So I'll first add in the length in meters and the estimated duration to the first line, and then I'll go through each of my maneuver legs, my route legs, and each of my maneuvers within that, and add the instruction text. So we'll just get a quick list of text of where we're going. And then once the user clicks that big button at the bottom that says voice guidance, we're going to pull out the stored lat and long and name of the final destination and launch them by building an MS-Drive2 protocol and then calling launch URI async with it. All right, so that walks us through 2/3 of the demo. The first part is where I haven't talked about, and that is actually launching into this app using MS-Drive2. And so to do that, we have to open up the WM manifest manually because the extensions isn't supported in the base way, the UI of modifying the WM manifest. So you just put in this extensions, and you say the protocol and give it a protocol name, and then these two other fields are just the defaults that you need to set that are given to you on MSDN. And then just when we're in here, let's sanity check ourselves and make sure that I added IDCAT map and IDCAT location. Good. We won't be crashing on first launch. That is excellent, not a way to run to end-to-end a demo. All right, after that, we're going to get launched in. Now we're going to get that MS-Drive2 called into our app. And so inside of the app XAML CS, we need to register for a navigating event, because this is going to come in a little differently than our normal page navigate. It's going to come in starting with this /protocol. It looks much like this. So instead of seeing mainpage.xaml as your start point, you're going to see this /protocol. And if you don't intercept this, your app will fail to navigate on your first navigate, and it'll be a little frustrating. So do this, register for navigating. You're going to have to go in there and I look for this preface, and if I see this preface on the navigation link, I'll remove it. I'll take out those 3 lat, long, and name parameters from it, and I'll cancel that navigation, and then take those 3 parameters that I escape the data, I unescape because they'll have the extra % encoding in, and I'll add them to the main page and then launch the main page. So then I can use the normal navigation context to grab those out when I'm done. So if I go back over to my main page XAML.cs, I skipped over step 8 here in the beginning, and that's because this is where I'm going to go grab and store off those 3 parameters to use at the end. And so I'm going to go in here and look at my navigation context. Navigation context is really cool because it gives you this query string ability that gives you a dictionary, so you can do a try get value for each of these. And so I'm going to attempt to get my destination latitude. I'll get a temp out string. I'll try to parse a double out of that. And then my sanity value is 360 because lat long, neither of them can be 360. And then I'll set that to my view model location, destination location for both latitude and longitude, and then I'll parse out the name. Luckily, this can be kept as a string, and I'm just slotting into the normal line 1 of the DataBind project. All right, let's hope it all works. So I'm zooming in. I can see all the different cars around me. I can see my location near the Space Needle. I'm going to click on the closest car. Now I zoom in, and I can see my walking route taking me through these nice paths in the park of Seattle Center. And it's going to be 772 meters or 13 minutes. And you can see each of the directions. You get these turn left, turn rights since they're park paths and they're not named. But if you're on a street, you actually get the street names. And then let's zoom, we walk for 13 minutes, at which point then the whole session would be over. But let's fast forward, and we'll say we're there, and we're at that car. And so we're going to click on voice guidance, and I'll get to select that I go right to here drive. And I'm going to get my directions from Redmond. Oh, no, from the Space Needle. There we go, here drive. And let's show that one more time, end to end. Now starting outside the app, let's start from a place, because I wanted to launch in using a place. So we'll do the same thing. We go into a place card for Golden Gardens in Seattle. We'll click drive. Now you'll see that my car share app comes up. So I'm going to click my car share app. Brings me back in. I can click my place, get my walking directions, click on voice guidance, now click on here drive inside of my car app, and now I get my directions. All right. So key takeaways. Use the control and services, use them correctly versus tasks, just like we talked about. Thank you. Stop navigation. Use the toolkit. We built those great UI time saver pieces in there, and it allowed you to data bind your lists directly to the collection of map overlays. Enjoy the use of our shared offline maps that allows you to use offline maps in your apps, which no one else does. And remember, you can use the same location code on Windows and Windows Phone in your apps as long as you're using the WinRT APIs. So some follow-up resources. The phone toolkit is available at phone.coplex.com. If you want to learn more about MS Drive 2 and other app-to-app communications and how to use it in your apps, there's a great session by Sean McKenna on that you can go watch the video for. And if you want to learn more about agents or other ways for continuous background execution, you should totally check out the App Foundations talk by Thomas Fennell online. And do please fill out the evaluations for this talk. Thank you, and if there's any questions, the mics are open. Oh, could you use a mic?
What is the difference between old control, Bing Maps control, and new here Maps control, or how it names?
So on Windows Phone, there is no Here Maps control. It's the Windows Phone map control that we worked with Nokia to integrate their Here platform, and together we're providing you this Windows Phone map control. And so that's the vector-based one that lives in the OS and has the offline maps ability. The Bing mobile control is the one that you include in your app and is tile-based, and those tiles are coming from Bing servers, and it's online only. Does that help?
But what should we do with the old control? Should we use new only, or could we somehow replace it?
Yeah, you can. So the toolkit's supposed to make it very easy for you to switch to the new control. I recommend when you have the chance to do that, but you can continue to use that Bing Maps control in your app as well. Yes?
Hi, are you familiar with the accuracy ring?
Yeah.
How would you go about building that?
Man, that's a good question. So I can tell you what we do is we have a whole bunch of PNGs that we scale in different amounts because it only stretches so well nicely, right? And so that's a tough one. We looked at adding that to the toolkit, and we didn't get to that. So that's how we implement it internally, at least, is it's a bunch of different size PNGs, and essentially if you get to a certain scale, swap it out for a more accurate one. So
the Here Maps, is that what they do, you think, too? I've seen their accuracy ring is like this circle that has an opacity. You think that might be a map layer? Yeah, I think I believe theirs is a map layer, so it would use the same type of tricks. They might be. I think there's polygons and XAML that you could draw, and maybe you just make that a XAML element that it spans and contracts, and just have XAML handle it. You could also do that. Yeah, I've tried my own control that expands and contracts when you pan the the map and also when you zoom in and zoom out, it's just
Yeah.
like super jittery and
Really? Okay, because you have to run that on, that gets run on the UI thread. So you have to wait for till you get an update.
well, and like you
Yeah.
were saying, the events are only triggering sometimes when a user interacts with like the view changing event.
I see. Yeah. So,
So-
are you doing this on the Bing control or the Windows
Both.
Phone 8? Both.
Yeah.
On the Windows Phone 8 one, I would expect a little less jitter, and if you've registered for the zoom level callback, you should be able to figure out the actual size based on that, because there's actually a formula to determine zoom level to number of pixels on the screen for a device. So
If
you
you're
wanna-
curious, if you're curious to see how it works, I have it on my
yeah,
on my
cool. I'll
phone,
follow
so-
up afterwards and check it out. That sounds fun. In the middle.
Is there a way like I can see what location source it is? Is it Wi-Fi or cell ID? Can I request a specific source?
You can't request a specific source. You can say that I want a really accurate fix, and you'll get a GPS fix of some sort. Or you can say I want a low accuracy fix, and we won't bother to fire up the GPS. And if you get a GPS fix, there's something called position source. And in position source, it will tell you that it came from the GPS. So you can, if you really need to, know that's from the GPS. And inside there, you'll also get the HDOP and VDOP errors of the GPS fix as well.
Thanks.
Yep.
I'm a little short. I have a simple question, but it's actually more about the UI instead of the platform itself. I hope you can point this to me.
Okay.
I have an app that I've made and published. It's one of the top apps for public transportation back in São Paulo, Brazil.
Great.
I'm using Bing Maps currently because
Okay.
I want it compatible with Windows Phone 7.
Understood.
Okay. But it's really on my plans to upgrade and migrate to Windows 8.
Yep.
So that UI kind of thing that does this, I've done this implemented by myself. I don't know if you can see it from
You're
here.
dragging up and down the map.
That
Yeah.
up and down UI
Yeah.
elements. Is that customizable? I mean, can I put anything I want on the Nokia HERE platform, or it's just for instructions on the locations like you showed up in the demo?
You can put your own data on top of that map control. Yes.
Okay, but I mean, can I create other lists? Like I've built this from scratch,
Right.
So you know, it's a panorama below it, and then there's a map control
Yeah.
upon it in the upper part. So I can interact with the stuff here, and I can add custom data binding and anything. Is this also possible in HERE platform? Because I've
Yes.
seen you didn't make any changes to bring this overlay up. So
Right. You should totally be able to move that overlay up. What I might suggest is not. Are you currently on the Bing one? Are you resizing the control as you slide it up, or is it behind and you're just hiding parts?
actually I don't remember right
Okay.
now. No, it's I've made this using a scroll bar and you know some tricks about
Oh, yeah.
fixing it up and adding some event handling on the touch to make it go up and down.
Oh, nice.
But it's actually just animations and scrolling. So I would like to know if it's possible to
Yeah,
do
it's totally
this.
possible. And if you actually look at the HERE Maps app, they've done something
Yeah.
very similar, and they used all Silverlight stuff to do that. So.
But this is now part of it, or is it
It's not
supported?
that slide up control is that's not part of the base offering. That's something that their app team went and built.
Ah,
on
so
top of the
actually,
map.
okay.
So you're in the right path. That you looks like you have something. To
Yeah,
start
I
with.
did it. I did the same,
Yeah.
but built it from scratch, so it's okay.
The other thing I might recommend you trying keeping the map control larger and just hiding part of the map control. And there's a property called Transform Center that allows you to transform the effective center of the map to a different location normalized on the map control. So essentially you could keep the control like whole page and move the center of the map control just to that top part of it. So then all your map interactions happen around that top part. Okay. So you might be able to do it without having to resize the control.
All right, thank you.
Just an idea.
The geolocator just give me the longitude and latitude. How can I get the altitude? It's always 0.
Altitude is always 0?
Yeah.
Yeah, I don't know.
And many other developers also asking for that. So,
On Windows Phone, it's always 0?
Yeah.
Okay, I haven't tried anything. My map controls 2D, so I haven't tried to position myself higher. But that's a good point.
Can you clarify one more time? When should I use URL MS Drive to, and when should I use route task?
So,
And what's the difference?
so the difference is the MS Drive 2 will launch into a third-party or Nokia Here Drive app to give you voice guidance immediately. So it's not going to give you I'll repeat the question. It was when to use MS Drive 2 versus the directions task. And so to do that, you're going to want to decide between the two if you're going to give voice guidance immediately, like you're going now in a car, or you expect your user to be going now in a car, use MS Drive 2 to launch out to Here Drive or another voice guidance app. If you don't think they're going to be actioning and moving immediately to that location, use the map directions task, because that will give you a route overview first that you can actually go through and look at the maneuvers on, right? Well, if you launch, the main one people are going to have is Here Drive, and Here Drive doesn't have a maneuvers list that you can like browse through and be like, oh, that's where I'm going, right? So it's really it's a immediacy thing. Thank you. All right. Thank you, everyone.